recording.
No, because I redid it.
I almost got an Oakley backpack, but just decided a different one.
Kyla's boxer weighs about 62 pounds. When it was a puppy. Weighs? Oh, no, I see. Okay. When it was a puppy, it only weighed 23 pounds. What is the percent change in weight? Round to the nearest tenth. So the puppy started out at 23 pounds. And then it grew. And it ended up being, where'd it go? 62 pounds. It looks like 621 BS and 231 BS, but 23 pounds and 62 pounds. So what should we do?
63 minus 23.
62 minus 23, right? That's what you meant. Okay, so 62 minus 23 equals 39. I think that's right. Yeah, that's right.
And then you do that divided by 23. Right above the initial.
You're right. Everything you've said is awesome. Good job.
And then you do that.
Noah, you have spiky head today. It actually kind of even looks good. I mean, it's kind of like mad scientist-y a little bit, but it works. I think it works.
That equals 1.6965.
Okay, so now what? Turn it into a percent. That's true. What'd you ask, Garrett?
Why are we turning it into percent?
Because we're trying to find percent change.
Oh, yeah.
So we're going to move it over twice and end up with, it says around to the nearest tenth. Is that what I just read? Yes. So 169.6%. Any questions on 30 first? Did we understand whatever we missed? Whatever happened?
I understand.
Who all? Okay, good. And you said number what?
8.
8. Didn't Britton ask for another one, though, first?
I said first and last.
Oh.
8 is the first.
And you said something else.
I said 28.
28. So 28, and then we'll do 8. There were 10,651 athletes who participated in the 2000 Summer Olympics in Sydney, Australia. In 2004 Summer Olympics in Athens, Greece, 11,099 athletes participated. What was the percent change in the number of athletes participating in 2004 round to the nearest tenth? So, in 2000, there were, what is it? 10,651 athletes, and then in 2004, I'm doing it right. There were 11,099. And we want to find the percent change. So what should we do?
Minus.
We should subtract.
Oh my gosh.
That is bad grammar, but who the heck cares? Communication is communication. It only matters if people don't understand you, and we do. So,
Thank you.
I mean, you don't sound as smart, but it's okay. You are as smart.
Is that in 2004 that 11,095, 94?
You've got the book right in front of you. Okay, so we're going to subtract what things?
The numbers. 10,651 and 11,099.
Yeah, but which one are we going to subtract from the other one?
11,000 minus 10,000.
Okay, so we're going to do the final, which is 11,099, minus the initial, which is 10,651.
And you get 448.
448. And then we're going to divide that one by what? 10,651. And we get...
And you get. I just my mom.
You can't jump ahead 2 steps and then say random, because at that point you're just saying random things. What do we get when we divide those?
0.04206.
0.0426. Wait.
I got a different answer.
When you divided these?
Yeah.
Did you divide it backwards on accident? Did you put this one divided by this one instead?
Yes.
Yeah.
And then if we compare it to
So now that we're on the same page, everybody, it's 0.042 what?
0.061. 778.
So now we got to convert that to a percent.
So we move the decimal back 2 times, and that would be 4.2%.
4.2%. Number 8. Oh, I didn't resave. Let me resave this before I forget, so that I don't overwrite the old file. That's what happens when you come in distracted. Oh, 421. This is pre-algebra, and we're about to do simple and compound interest. Sort of. We're going to do simple and compound interest, the, what am I saying? The middle school, well, not middle school way. Well, yeah, it is the middle school way. I was doing something earlier today in geometry class that was like an eighth grade thing. True facts. Math is spiralical. What would the word be? Who knows? It spirals up and up and up. What was old will become new. What are we doing? 8? Is that what you said? Mm-hmm. Garrett, are you doing the Algebra 1 summer intensive?
I am.
Okay. You are?
Is there 3
Are you signed up already? Because you're not yet.
I kept telling my mom. I told Michelle the other day that we're gonna sign up.
Okay.
So
And I am also working on that.
Okay.
if you don't believe me, you can call my mom.
I believe that you believe it. I also believe that your mom probably wants you to take it, which is good. I believe that. It makes sense. 248. And Noah's thinking he's going to sign up too.
Is there 3 people in that case?
There will be 3 people at that point. I think because I think there's somebody else signed up, but I don't remember who they are. Nobody else in here is doing that one, right? Right? No. There was a question mark with you, but I think it's a no. I don't know.
A bunch of volleyball camps and stuff, so I'll miss all of it.
Because your dad was talking about it, but then
He
your grandma was like, I'm not sure, and
wants
so
me to do it, but I'd miss I have volleyball
Yeah.
camps all the whole month. So.
yeah, and you can't miss any. So yeah, that's fine. I think probably doing it in a year would probably be better.
When
Anyway,
you say if you miss one, are you allowed to
It'd be better if you didn't, but I guess we could make that work if we had to.
Okay, yeah, so I might have to zoom in for one of them.
Okay, you going like out of town or something, or?
I think so. I remember. I just remember me being like, oh, wow.
I could probably make that work. Because that would, but yeah, you wouldn't really be able to totally miss, but we could probably make that work if we needed to. I bet. Okay, so we're having a change from $36 to $48. So what are we going to do?
48 minus 36.
48 minus 36, which gives us 12, and then we're going to divide that by 36, and we end up with 0.300000, etc.
I thought it 0.
Oh yeah, you're right. 3. It doesn't matter. Same difference in context. They're all 3s. What are we supposed to round to? Tenths. So when we convert that to a percent,
That'd be 3.3. No, 3.
it would be 33.3% increase. Blapo.
Whenever you wrote it down, it was like 80.
No, yeah, you wrote something else up there, because I got it right then.
I read the wrong thing.
Well, thank you.
You're welcome. I'm glad to freak you out.
So was the answer actually?
The answer to number 7 is 85.7%.
What is the answer to number 8? 30%?
33.3% increase.
Oh, so we were wrong.
It was not 30%, it's 33.3. It's you probably just over rounded.
No, I got 12 divided by 30. I thought that 12 divided by 36 was 30. 3.0000000. Or 0.3000.
What does that actually reduce to? That reduces to 1/3, doesn't it? Yeah. 1/3 is 0.3333, etc. So you thought wrong. You should have verified, sanity checked. It's okay, I made the same mistake when I was rushing just a minute ago. So you're welcome. Make you feel better about your life. Other people make mistakes too.
Will you problem 18? I had trouble with 18 to 20. How's that?
Yeah, we can do one of those, sure. The markup problems. So number 18, we had a bracelet that is $26.50.
Sure.
And there's a 35% markup. What? It's really not, though. I mean, it doesn't say what kind of bracelet it is. If it's like a silicone bracelet, that's really expensive. But if it's like an actual jewelry bracelet, it's really cheap. So kind of depends. Maybe it's at a pawn shop and it was stolen. Report him. Okay, so what should we do to solve this problem?
I couldn't figure out the markup problems.
You had 1 or 2 examples in your notes and in the textbook.
Convert 35 to a decimal.
Sure, that's a way to do it. Why not? Let's do it that way.
Dollars over 1.
Now what?
I didn't do that.
Yes, you did. You put it over 100, which is the same thing. True facts. It also works. Percent of something, yes. So,
Apply 26.50.
yep. And what do we get?
92.75.
Oh, that should have been a 6, shouldn't it? Sorry.
You get 92.75.
I don't think so. I think you did 35 instead of 0.35, I think.
35 point.
Oh, and then over 100? Oh, you're tricking me.
I got 9.
35 over 100 times 2650, and you get 90. What did you say, 92? That sounds right. 92.75?
I got 9.2.
9.275, yeah.
Oh, good Lord. Okay. When you do all of that, you end up with 9.275. Is that what y'all are saying? Great. Okay, now I'm following you. Is everybody else following?
Yes.
Why not? Where are you?
I'm lost completely. So what in the world are we doing?
This is what we actually did right there on the page. I just thought we were saying something different.
35 to a decimal.
You can. That's what I started out. That's what I thought we were doing. But she's trying to trick me.
So we did 35 over 100.
Times 35 times 2650 divided by 100. Enter. Just like we've always done, buddy. Just like we've always done. You can put that over 1, right?
Oh, I see now.
Good. Just good. I'm glad.
And then you plus.
Yeah. And then we'd add those together. You can blame it on Bryn, Garrett. She was trying to confuse you.
Could we also do 22?
No. We don't have time. It's not any different than this one. Is there something specific you're confused about?
No, just us. I got the other two of them right and 2 of them wrong.
Okay.
We did.
So go back and check through your math. And if we need to, and if we have some time at the end of class, we can come back and hit them. But we need to do today's lesson. But yeah, we can if we have time, we can come back and hit those.
He's your son. Y'all can just do that at home.
We can.
Don't drag us into this.
Fight. Okay. All right. We are. For now. If we have time and we need to come back, we can. Which we may, because this lesson is not super long either. This lesson is a funny lesson to have in this part because this is really an exponential function problem, but not the way we're going to do it. We're going to do it with the knowledge that we have right now, which sounds great. Lesson 7.7. Yeah, we're in unit 77. That's right. OMG. I would never be sarcastic. Never. You know, there's some people that think that sarcasm is always bad. What a terrible thing. Sarcasm can be bad. That's absolutely. Like, sarcasm can be rude, and be disguised as a quote-unquote joke. Absolutely. But sarcasm between two intelligent human beings can be funny and fun and great. Simple and compound interest. So anytime, now we're not doing it, we're not actually using the full formula because we don't know about exponents yet. But anytime we talk about compound interest, I feel somewhat obliged to have a brief moment of a very important soapbox. You ready? Y'all are all young, yes? We're going to look at a really simple version of this formula. Compound interest is interest on top of interest. So if you put $1,000 in the bank and that bank earns you $150 worth of compound interest, then the next year you'd get $150. And then next year you'd have $150. And then after that, after that, it would earn interest off of that interest. And the way this works is, and you'll see this better when you go to Algebra 1 and you learn about exponential functions. The way it works is you can put a little bit and the function looks like this.
Exponential growth.
It is exponential growth. And the point is right now, and I don't have enough time to go into it, and y'all don't know about exponents, so we can't really look at it. But the point is, if you start saving money now or early, you end up with a whole lot more money when you're older. Because wherever you start this, you're going to end up with less and less. So the point is, invest early. Invest wisely in things that have smart, long-term track records that aren't going to lose you a bunch of money. But invest early, and you can become a millionaire way quicker. It's a smart thing. Also, here's your public service announcement of the day. None of you, not a single one of you, should expect to receive anything from Social Security when you retire. It's probably not going to be there. So invest your own money. True facts. Well, at least that's the trend. And that's not actually a scary thing. It just means you're responsible for you. Tough nuggies. Okay, so here is the formula we're going to use. You ready?
I equals B.
This formula is the simple interest formula. Okay. Let's label what these variables are so we can know what's happening. I stands for interest. So interest is the amount of money that you gain, or amount of whatever. We're pretty much always at this point looking at money. You can apply these concepts to things like bacteria and a lot of other stuff as well, or rabbit populations, all kinds of things. So this is the amount of money you earn from interest. P stands for principal. Anybody know what principal is in this context? Good guess, but no. It's the amount invested. So it's whatever you put in. To your investment. R.
Productives.
What?
They said the random word.
Is the rate. It's the interest rate. It's always a percent. Usually we write it as a decimal. But it's the percent. So these two, I didn't write this, but the principal is in dollars. The interest is in dollars, right? And the last, the T, what do y'all think that stands for? It does stand for too valuable. It stands for time. Time in years. You were just guessing, but you were guessing a guess that makes sense. All right, so let's do a few examples with simple interest. The instructions on these examples are going to be find the simple interest to the nearest cent. Oops. So the first example is going to be $1,000 at 4.5% for 2 years. Okay. Okay. So what we're going to do is we're going to plug this into our formula. So our formula is I equals PRT, right? So we're trying to solve for the interest. So now what we're going to do is, just like we always like to do when we substitute stuff into a formula, we're going to put parentheses where the letters are. And then we're going to stick the numbers in the parentheses.
Wait, what about I? When you want for I?
That's what we're solving for. So we're going to leave it as an I.
So we put
So the 1,000 is the principal, right? We're going to put the percent in. We cannot put the percent in as a percent, right? So we can put it in as a fraction or a decimal. What do you want?
decimal.
Sounds fine. So you can do it, if you want to do it different than what I'm writing, that's fine. You'll get the same answer. So how would we write 4.5% as a decimal?
0.045.
Yeah, so we'd take the decimal place and we'd move it twice. And end up with 0.045. And then time in years is 2. And because of the place we are in the scores, you're going to pop that in the calculator and push enter.
All that
So it
times
equals
is
90? Would that be $90 again?
I don't know, would it?
Each other?
Yep.
So all that.
How would it equal 90?
So it's 1,000 calculators total.
So did you put it in your calculator and you got 90?
90.
Okay. So it's easier to think about it, in my opinion, if you want to try to think it through. It's easier if you put that as a fraction instead. Because watch this magic. What would happen to these zeros and those zeros? So this would go plap and then plap. So 2 times 45.
2 times 45 is 90. But times 10.
What did oh. It's because I didn't do that right, did I? How about 4.5 over 100? 4.5 times 2 is 9. Times 10 is 90. Still 90. Divided by 1 again, it's still 90. Does that help? Okay. So, the answer is $90.
Woo, we just gained $90.
$90 after 2 years, which isn't that great. Simple interest. Simple interest is not as exciting. Okay, so let's do another one. We'll do this one as a GP. So GP number 1. We're going to invest $2,500. By the way, for purposes of thinking through things, in example 1, how much money would we actually have at the end of 2 years? 1,090, right? You'd have to add it back. Okay.
But I is the interest gain.
Yes. Okay. 2,500 at 6.75% for 3 years. Okay, ready to go. Okay. That's what should have happened.
What decimal compound?
What decimal, buddy?
So on P, or not,
You can't put percent in. You have to convert it to a fraction or a decimal. One of the two. Example 2. Oh, yeah. So, the difference between simple interest and compound interest is that compound interest, you gain interest on top of interest. So using the only formula we know, this t will never be more than 1 on a compound interest problem. Let's look at what I mean.
So it can't be 0.
Well, yeah, it definitely never would be 0 on any type of problem.
0, then it's,
Yeah,
yeah.
yeah, nothing. Definitely will never be 0 on any type of problem. On a compound interest problem, it has to be 1. Let's take a look at an example. This is example 2. What is the total amount of money in an account where $600, oops, is invested. At an interest rate of 8.75%. Compounded annually for 2 years. Okay. So, this is how you have to do one that's compounded annually right now. Later, when you learn about exponents, you can do all this with just one formula. But at this point, you got to just repeat the same formula for as many years as you have. Okay, so our principal, our initial principal is what?
A, 600.
600. Our interest rate is what? 8.75. We need to convert that to something useful, so let's do that now while we're thinking about it. So that equals what?
0.0875%.
I would not convert it to a mixed number. But it does. But that's not quite right because you got to move the decimal, right?
Wouldn't it be 0.087?
So it'd be 875 thousandths. Or would it be 10? It would be 10 thousandths, wouldn't it? Or 0.0875, which is also 800, which is also properly said 875 10 thousandths. All true. Okay. So, this is what we got to do. We got to do year one. Okay. In year one, we're doing this. We're going to figure out how much interest happens. So that would be putting 600 in for the principal, right? And the rate would be 0.0875. And the time would be 1 year. So punch that in. Ready, go. You could if we were doing simple interest.
105.0.
It doesn't sound right.
52.5.
Yeah, I got 52.5. So.
What'd you do there, Garrett? Did you punch this in?
600 times 0.0875 times 2.
Why'd you do it times 2?
Times, yeah, sorry,
Okay. So this equals $52.50.
Mr. Sean,
Yes.
from this, then would we add 52.5 to 600?
Yes.
Process?
Yes, we would. So we need to look at how much money we have after 1 year. So to figure out how much money we'd have after 1 year, what would we do now?
Plus 600.
Plus our 600. That's right. So it'd be 652.5, right? After 1 year. So then in year 2, we're starting with this new principal. Because for compound interest, we get interest on top of interest. So our new P would be 652.5 times 0.0875 times 1. So what do we get when we do that?
57.09375.
$57.0938.
So $57.09, right? So to finish this problem out, what's the one more thing that we need to do? Plus what?
Add the two later.
What are we adding?
To 652.5.
652.5.
Adding the 2 years. Basically.
We're adding to what we had at the beginning of year 2. What we had at the beginning of year 2 was this amount, right? And we're adding that to our new amount of interest.
Yeah, we're adding the 2 years.
That's, yeah. Englishly, that's not true, but but it sounds like you know what you mean, regardless of words used.
Is that a good amount of money?
It is a good amount of money, but then it would get even more after that.
So it just keep getting higher and higher.
Yep.
So if you compounded that annually after a long time,
You would have a lot of money.
what happens if you
This is not even all that, it's not a terrible, this is not not all that great of an interest rate, but let's see. If you got a summer job and earned $600, which is totally feasible. Totally a feasible thing to do. Let me see. Oh, my case is busted. But my phone isn't.
I think the subscriber.
Yay! Are you up to? You're well over 100. How far are you now?
179.
That's great. Initial investment. What are we investing? $600. with no other contributions. So let's assume y'all are 20 years old. You're not, but let's assume you wait until 20 years old and then you retire at 65, right? So how many years is that? 65 minus 20 is 45 years. So if all you put in is $600, which you could make tomorrow, maybe, at least within a year, easily. Even at a minimum wage job, you could make $600 that you could put in for a year. Estimated interest rate is 0.0875, which again is not that great. You can definitely get mutual funds that get closer to 15, definitely. Calculate. That's not right. Oh, because it's interest rate and not in 8. It's in percent. What is it, 8.75?
Yes.
It just told me you would have $624, which clearly that's false because we had more than that after 2 years. Without putting any more money in, none, only $600, you'd have $26,149. Well, just a bank account wouldn't do it, but in a like a proper mutual fund, it would. If you kept adding more, then it'd be even more. If you did, let's say, if you did 600, if you did just $600 a month, and that's it, or $600, no. If we do $600, how much would that be if we divided that by a year? That'd be what, half? So $50 a month would get us $600 in a year, right? Right? Does that sound right to y'all? So if we did $50 a month, and we did the same thing. So if you put $50 a month from year 20 to year 65, you'd have $318,147 at that interest rate. Yeah. And that's not even very high amount of investment. That's like little investment. But if you did, now for comparison's sake, this is important. So if you did the same thing, but you waited, if you did the same thing, but you waited until you were 45 years old, so 20 years instead of 45 years, you would only have $33,000. So starting early made, in this example, made a 10x difference. So if you started working at 15, you could even have even more.
I started working when I was 13.
Not legally. You might have started working within your family, which is legal, but you can't have a real job until you're 15.
Yeah, well, I'm just going to my youth house.
But you should start actually saving your money.
Yes, that's what I'm
Don't do like what I did and not save your money.
Well, I saved my money, but then I picked
And then you spend it.
so I spent it on
You had to play ballet and what?
ballet magnet.
Oh, ballet mag. Gotcha.
Oh no, he brought.
I thought you said and Epcot. I was like, why did you have to pay for a vacation? I'm confused. Homework is on pages 376 through 377, numbers 10 through 32 evens. Blapo. You can spend the last 4 minutes doing that, or you can get up and wander around aimlessly. It's up to
I would
you.
love to do that.
Okay.